As a general rule, the conditional variance is a random variable that depends on the value of y. But it could also be conditioned on x itself. For example, the value of a retirement package is modeled by a function. Let's find the variance given that the value is at least 10. So we want to find the conditional variance of x given that x is greater than or equal to 10. So this is going to require us to find the conditional probabilities, which means we need to find the probability of the condition, which will be Next, we'll find the conditional expectation, which, because this is a continuous PDF, will be the integral of the product of the payoffs and the probabilities. So we can rewrite our conditional probability. And since we're integrating from 10, we automatically meet the requirement that x is greater than or equal to 10. So this probability is just our PDF. And so we find and the expected value of the squared values is going to be and so our variance will be the difference between the expected value of the square and the square of the expected value. Or let's consider another case where the number of tornadoes is a Poisson distributed random variable with mean 3. Let's find the variance given that at least one tornado occurs. So again, if x is the number of tornadoes that occurs in a year, we want the conditional variance. Note that we can start our summation with k equals 1 because the value of the term in our series when k equals 0 will just be 0. We need the expected value. Now, since this is a Poisson distribution with mean 3, the probability that x is any specific value is, and the probability that x is at least 1, well, that's 1 minus the probability that it's 0. And consequently, for k greater than or equal to 1, our conditional probability will be Now, we can remove the constant factors from our summation. And note that our sum can be obtained by differentiating the power series for e to the x, which will give us, and then if we multiply by x, and then let x equal 3, we get our series. And so we find the expected value of the square is going to be, substituting in our conditional probability. So our power series for x e to the x gives us one factor of k. If we differentiate again, we'll get a second factor of k. Then multiply by x to get that back to x to the k. And if we let x equals 3, our series will give us and so the expected value of the square will be, and so our variance will be the difference between these two terms, which will be